So here we have a plane flying on a true bearing of 320 degrees for 450 kilometers. Then it flies on a true bearing of 350 degrees for 130 kilometers. And finally they change the bearing to 50 degrees for another 330 kilometers. How far north of its starting point is the plane? Well, I'll tell you. First of all, we'll need some reference, right? So let's create a starting point, a sort of a Cartesian plane. I'm going here because I know where this is going. So this plane starts off 320 degrees. Now 320 degrees, that's of course short of 360 degrees, but it's more than 270 degrees. So it's somewhere here, right? If the plane starts in the origin, they would go there-ish. And the angle here, sorry, not all the way around there, from the north there, would be 320 degrees. The distance, 450 kilometers. Then it flies on a true bearing of 350 degrees from the north. Well, the north is still the north. It didn't change. So I can just create a new north line there at the point where the plane now is. So the plane's now here. And I've got a new north pointer. Here I've got a north pointer as well. So from this dot, it's going on a course of 350 degrees, which is almost full circle. So it's going up very steeply there. So it is 350 degrees for 130 kilometers. So now the plane's here. Again, I can get myself a north pointer there, like that. Because all these north lines, they are parallel. Now it's going to fly 50 degrees. Well, 50 degrees, that's that way. 50 degrees. 50 degrees from north for 330 kilometers. How far is the plane north? Well, it is a problem in 3 steps. So we'll have to figure it out in 3 steps. The plane took off here, and after a while it ended up here. How far north did it get? Well, it got that far north from the starting point. So how far is this distance? Well, if you can see the triangle, and we can figure out the angles, if I am 320 degrees around, that means I'm 40 degrees short of full circle. So there's 40 degrees there. The hypotenuse is 450 kilometers. So this distance here is, if you're good at trig, 450 cos 40 degrees. The cosine of the 40 degrees is the adjacent over the hypotenuse. I'm looking for the adjacent, so it's the hypotenuse times the cosine of 40 degrees. Now I'm going to do the same trick for the second leg of the flight, which is from here to here. And again, I can create myself a triangle like that. I'm at 350 degrees course, so that means the angle there is 10. The hypotenuse is 130. So the adjacent, I'm again after the adjacent, is 130 cos 10. And that gets me there, so far north. Yeah. For the third leg of the trip, I'm starting here, I'm ending here. This 50 degrees here is from the north, but the angle in the triangle that I'm after, the triangle is now here, it changed it a little bit. that angle in here is 40 degrees. Yeah, it's just 40 degrees short of 90. 50, 40, 90. So now I'm no longer after the adjacent, because this triangle is oriented in a different way. I'm after the opposite here. I'm after this distance, the opposite. So instead of the cosine, I need to use the sine function, SOHCAHTOA, opposite hypotenuse. So this is 330 hypotenuse times the sine of 40 degrees. So how far north from my starting point did I get? Well, in the first leg, the northerly distance that I did is 450 cos 40. Then in the second leg, it went up and it did 130 cos 10. And in the third leg, it did 330 sine 40. How much is that? Well, I'll just grab my calculator to do that. Oh, I've got it right here. It's 212 kilometers. No, that's not true. That would be a bit too little. 450 cos 40 plus 130 cos 10 plus 330 sine 40, 684.9. In three significant figures, 684 kilometers. And that's just how far it got north from the starting point. In a similar way with triangles again, you could work out where it is from left to right, where it is on the east-west scale as well.